This is a miter rule for the Octagon roof, and it is 5 inches by 12 inches with a hypotenuse of 13 inches. Now, all unequal intersecting pitch roofs have miter rules to clarify the geometry and how to punch them in to your calculator. Everyone will snap them out whether they know the function of it or not, just to give them a sense of what's going on. This, for example, if you thought of these as rafter runs, this, as we know, is 5 inches. If it had a 5-inch rise, that would be a 5-5, which is the same as a 12-12 pitch roof. And this one, with a consistent rise of 5 with a 12-inch run, would be a 5-12. So this would be a 12-12 intersecting a 5-12. The Hipper Valley would be running at 22.5-degree angle in plan view. Now, if this was a 6-12 to a 12-12, this would be 6 inches here. How do I know that? Well, what happens when you have unequal intersecting pitch roofs is that you have to average the Hipper Valley between the two. And so if you average them, you have to average the two pitches now. Otherwise, one of the shallow pitch would go underneath, or the steep pitch would go above the hip. And so the way to average pitches is you write them out like a fraction, 5 divided by 12 or 6 divided by 12, and you would average the two. But since we know that the denominators of both pitches are the same, a 6-12, 5-12, you can just drop them. Because anytime you're averaging something, you're dividing by each other. Get rid of the bottom numbers and just divide the two rises by each other, and then multiply that by 12 inches on the miter rule, and that will give you the run. So I could go over that, but it's a simple formula. Every pitch, in unequal intersecting pitch roof, has its own miter rule. This also, so give that a shot. Take the rises, divide it by each other, multiply by 12 inches to give you the other leg of the miter rule. It doesn't matter what the pitch, even half pitches, it doesn't matter. But this also gives you the side cuts and deductions, or I shouldn't say the setbacks of the Hipper Valley, not deductions, setbacks. So if you have this, and this is the center line of a hip, you got 3/4 on either side, it'll give you the setbacks, like we discussed before, how far to go back to set your saw, Remember, this is on the level. This is the side cut of the steep jacks. This is the side cut of the shallow jacks. This is inside the building, obviously is the corner of the building, this is a schematic of the building. If you took this outside the building, this would be the overhang. So for a 5-12 to a 12-12, that means you're going to have, for every 12 inches of overhang, the other side will be 5 inches, which won't fly. You have to swing it off the corner. So the difference between a 5 and 12 is 7. So this particular roof, you would swing with that 5-inch overhang, you'd swing it off the corner 7 inches. You double the overhang, you would double how far off the corner, right? You would go. So if it's 10 inches and so forth. And so then you'd overlay your common rafters with the height above plates or the heel stand, and then the difference between the two would be how much you'd raise your plate up to accommodate the steep side.